Rule number 5, powers of powers with dividing bases. Okay, powers of powers with dividing bases. This is what I mean by that. Example number 1. We have x to the power of 4 divided by y to the power of 3. Now these are different bases, and notice our powers are dividing here. So we have x to the 4 divided by y to the power of 3, and this is all to the power of 2. Okay, let's see what happens here. So that means x to the 4 divided by y to the 3 times x to the 4 divided by y to the 3. Okay, the exponent 2 means you're multiplying it by itself. All right, so when we multiply, well, before we actually get to the multiplying, the x to the 4 is x times x times x, 4x's multiplying each other. The y to the 3, we have 3y's multiplying each other. All right, and that is multiplying itself again. All right, so we end up with 8x's multiplying each other in total over 6y's multiplying each other in total once we remove the brackets. All right, so we end up with x to the power of 8 divided by y to the power of 6. And notice that's very similar to the 2 multiplying the 4 and the 2 multiplying the 3. Okay, so when you have x to the 4 divided by y to the 3 all to the power of 2, that's the same as x to the 4 times 2 divided by y to the 3 times 2. It's as though the 2 came in and multiplied these powers. Okay, notice this only works if the bases are different. Okay, if they're the same, you would simplify inside the brackets and then bring your exponent in. All right, here's another example. X to the power of 3 divided by y to the power of 2 all to the power of 5. Okay, which means x to the power of 3 divided by y to the power of 2 times itself 5 times over, which is x times x times x. Let me move that over a little bit. X times x times x divided by y times itself 5 times. All right, so we end up with 1, 2, 3, 4, I'm thinking 15, 6, 7, 8, 9, 10, 11, 12, 13, 14, whoops, a daisy, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, okay, I was right, divided by, let's see, 10 perhaps, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 y's. Okay, so we end up with x to the 15 divided by y to the 10, and that's our answer. Okay, but notice that the shortcut, we could have just multiplied the 5 times 3 and the 5 times 2. Okay, so notice that x to the power of 3 divided by y to the power of 2 all to the power of 5 is similar to, or the same as, x to the 3 times 5 divided by y to the 2 times 5. All right, and that's our rule. Our rule is when we are if you have powers of powers, even if the powers are dividing inside the brackets, that the exponent on the outside of the bracket is going to multiply all the exponents on the inside of the bracket. Okay. So, example number 1, if you have x to the 12 divided by y to the 7, and these have different bases, right? If they had the same base, you'd simplify first. They have different bases, so the 20 is going to come in, multiply the 12, and multiply the 7 exponent. Okay, and that will give us x to the 240 divided by y to the 140. Example 2, if we have 3 to the 19 divided by 2 to the 16 in brackets, all to the power of 5, that 5 is going to come in, multiply the 19, and multiply the 16. So we get 3 to the power of 19 times 5 divided by 2 to the power of 16 times 5, which is going to give us 3 to the 95 divided by 2 to the 80. Example 3, if you have 2 to the 9 times r to the 11 times s to the 7 divided by 5 to the 3, x to the 8, y to the 4. Notice these are all different bases. If they were the same bases, you would simplify first, right? So that's going to give us, the 10 is going to come in and multiply all the exponents, okay? Notice the 10 is not multiplying the 2. It's multiplying the 9, the 11, the 7, okay? So we have 2 to the 9, r to the 11 times 10, sorry, 2 to the 9 times 10, r to the 11 times 10, s to the 7 times 10, divided by 5 to the 3 times 10, times x to the 8 times 10, times y to the 4 times 10, which gives us 2 to the 90, r to the 110, s to the 70, divided by 5 to the 30, times x to the 80, times y to the 40. All right, and that's it for example 3, and that's it for rule number 5. Have a good day.